Hello, this is Professor Dan Kernler of Elgin Community College. This video is part of my statistics series, and in this video we look at various measures of center. Let's get to it. So one of the first things we want to look at when we have a variable is like, what's a typical observation? What's the middle? What's the average, etc. And we're going to have three different options depending on the type of variable and then some characteristics. So first, if we're going to split it up between categorical, which is just descriptive, and then quantitative, which would be numerical. When you have a categorical variable, residence area, favorite color, maybe response to a survey question, then the measure of center is the most common, that's the mode. When you have a quantitative variable, you can either give the mean, which we'll describe specifically, that's like the average, or the median, which is the middle value. So let's dive in and look at the mode. I've got a few examples here. One would be in our LGB database. We've got the political party, and you can see the most common is Democrat, so that would be the mode. It's the most common. Current happiness. The most common here is the people are pretty happy, so that would be the mode. One question in the survey was they've tried to stop being attracted to people who are the same sex. Again, this is a database made up exclusively of LGB, lesbian, gay, and bisexual. So all have some attraction to the opposite sex. So here's the survey responses, and it was a 5 scale, strongly disagree, disagree, agree, somewhat agree, and strongly agree. We can see here that the mode would be strongly disagree. Okay, back to those measures of center. What if we want to look at the mean? Technically, it's formally called the arithmetic mean because we're adding here. We typically just refer to it as the mean though. And we're going to look at two different possibilities here. One is when we have a population and we use the Greek letter mu here. That is their version of m. So we use the Greek letter mu, and this is like what you have referred to in the past as the average. You just add them up. That's this subscript x sub 1, x sub 2. You add up all the observations, you divide by how many there are. For the sample mean, we're going to use x with a little bar, and we just call it x bar. X bar, same thing, add them all up, divide by the sample size. This is pretty easy to do in StatCrunch. You just go stat, columns, and then pick your variable. And then down on the bottom, you can decide which statistics you want to compute. Let's give the sample size here, and then we can compute the mean. Now, one note here, there's a bunch of decimal places, and we want to know where to round to. So we always round the mean to one more digit than the data. So these were given to us as ages just to the nearest year. They didn't say 15.6 years. They gave 15 years, 20 years, 6 years, whatever. So we want to round to the 10th place. In this case, that would mean that the sample mean, x bar, would be about 16.0, one more digit than the original data. And you can see that here I have a histogram, and that 16.0 is actually like the balance point. That's what the mean is. It's where it would balance. It's kind of like the center of mass if you had physical objects here. Okay, back to the measures of center, and let's focus in on the median next. If we have 11 individuals lined up here, 1, 2, 3, 4, 5, up to 11, the median is the one in the middle. That would be the 6th one here. There's 5 above, 5 below. You're splitting it up 50% below, 50% above. Now, with a sample size of 11, it's kind of weird because there's not 50% above because the 6 isn't included. So typically we're talking about these with large data sets. So it's splitting it up into half above, half below. Let's use StatCrunch for this. Same menu, stat, columns, and then choose our variable. Let's look at the 2018-2019 school data and look at the percent of students who are Black or African American. And let's do the sample size, and let's do the mean and the median as well and get all three of those. So here's the histogram, and we can see that the mean is 19.6, but the median is way over here, 4.7. 4.7. The median is 4.7, pretty small. And that's because these values way over here on the right pulled the mean up and made the mean higher. This is a really important fact that the median is resistant to those outliers. So if you have data that are skewed, like this variable is pretty skewed, then you want to use the median because, again, it's resistant to outliers. Now here's an example of how this can be used. Here's a press release from the press secretary for President Trump, one of his press secretaries, and there was a tax cut plan, and she tweeted out that the average American family would get a $4,000 raise under the president's tax cut. So they would pay $4,000 less in taxes. The Tax Policy Center from the Urban Institute and Brookings Institution found that in 2018, taxes would be reduced by about $1,600 on average. But taxes are based on income, and income is very skewed. So let's dive a little bit deeper into this. This is in their report. This was from the Tax Policy Center. This is the average benefit from the tax bill. So you have the incomes here, and then what they would benefit from the tax bill. So we need to know, where is the average American? Because income is skewed, we should use the median. That's a little tricky to find, but I have some data here, and we're going to use that to analyze and get an estimate of where the median is. So looking at the income distribution, we're going to use this data to try to find out where the median would be. And we're going to have to do a computation. What we want to compute is the cumulative relative frequency. So adding up to that particular income level and then divide by the total. So we're going to have to compute an expression. And we're going to have to dig in the menu. We want to find the cumulative sum. That's adding up to that point. And then we want to divide by, we've got to scroll all the way down when we want to divide by the sum of all of those. And when we do that, if we scroll around, we want to find where it's about 50%. That would be the cumulative relative frequency, where 50% would be below that. That would be the median. So if we dive in here, it looks to be about $65,000 or so. So if we come back to this table from the Tax Policy Center, we had about 65,000. That would be here. So if we zoom in there, we can see that the median income, or the median tax break would be about $870 only. Certainly not $4,000 from the press secretary, and not the $1,600 that the report said either. One last final note here is, looking at the mean and median lets us know something about the distribution shape. For example, if we have some right skewed data, the median would be here and the mean would be pulled up by that right skew. Whereas with left skewed data, we have the median, and then the mean is pulled down by that left skew. Whereas with symmetric, the mean and median are going to be approximately equal. So this is useful if you don't have the histogram, but you have the mean and median. You can use those to also get an idea about the shape of the distribution. All right, that is it for this video. Thank you so much for watching. If you're interested in watching more of these, you can subscribe, hit the bell to get notified when more of these come out. There's going to be a whole series. I also want to take a moment to thank the Elgin Community College Board of Trustees, which approved my sabbatical during the 2021 semester, and that allowed me to make this whole series of videos. Thank you so much for watching, and I will see you in the next one.